So in the previous video, we had asked ChatGPT to generate 10 college-level algebra, trigonometry, and calculus questions. In the previous video, we had solved the algebra problems. In this video, we're going to solve the trigonometry problems, and in the future video, we will solve the calculus problems. So let's begin. For the first trigonometry question, we are asked to find the value of sine 45 degrees plus cosine 60 degrees minus tan 30 degrees. To solve this, we could use our calculator or the unit circle to find the values of sine 45 degrees, cosine 60 degrees, and tangent 30 degrees, after which we can do the arithmetic. For the purpose of this video, I will just draw the unit circle and locate the various angles. So over here, roughly you have 60 degrees. Somewhere in the middle here we have 45 degrees. And down here we have 30 degrees. Now the x and y coordinates on the unit circle correspond to the cosine of the angle and the sine of the angle. And so for an angle at 30 degrees, we know it is located at the point square root of 3 divided by 2, 1 over 2. For 45 degrees, we have square root of 2 divided by 2, square root of 2 divided by 2. And for 60 degrees, we have 1 over 2, square root of 3 divided by 2. And then we can conclude that for sine 45 degrees, that is square root of 2 divided by 2. For cosine 60 degrees, that is 1 over 2. And tan 30 degrees, remember tan is the same as sine 30 over cosine 30, which is 1 over 2 divided by square root of 3 over 2, which is just 1 over square root of 3. And if we rationalize, we can say tan 30 is equal to square root of 3 divided by 3. So now we know the sine, cosine, and tangent of the angles. We can plug it into the question and carry out the arithmetic. So here we can now say sine 45 degrees plus cosine 60 degrees minus tan 30 degrees, which is now equal to rad 2 over 2 plus 1 over 2 minus rad 3 over 3. And for us to carry out this arithmetic, we have to know the order of operation. And so we could use PEDMAS or BODMAS. They are pretty much the same, and we see that A comes before S, and A stands for addition and S stands for subtraction. So we will just have to add these terms first and subtract this term from whatever we get in here. And so when we do that, we'll have square root of 2 plus 1 divided by 2 divided by square root of 3 divided by 3. And when we calculate further, we'll have 6 here as the lowest common multiple, 3 here, square root of 2 plus 1 minus 2 root 3. And you could choose to simplify further and say this is equal to 3 square root of 2 plus 3 minus 2 multiplied by the square root of 3 of this divided by 6. That's the answer to the first problem. For the second problem, we are told that given sine of x equals 1/2 and x is in quadrant 2, find the value of cosine x. This is a unit circle problem, and so to solve this problem we need to draw the unit circle. And we are told that an angle x the sine of the angle is 1/2. Sine equals opposite over hypotenuse, which is equal to 1/2. So, if you come up to a unit circle, we could obtain a right angle triangle by drawing a vertical line that will be perpendicular to the horizontal axis. Hence, we'll now have this. Where this is the angle x, 2 is the hypotenuse, and 1 is the opposite. And this is a right angle triangle. And now we are asked to find the cosine of x, which is the adjacent divided by the hypotenuse. But we don't know the adjacent. But we could use Pythagoras theorem to find the adjacent. Let's call the adjacent c. And so from Pythagoras theorem, we know that 2 square equals 1 square plus c square, which implies that c square equals 2 square minus 1 square, which equals 4 minus 1. As a c square equals to 3. Therefore, c is equal to the square root of 3. Now that we know that c is equal to the square root of 3, we can now conclude that cosine x equals square root of 3 divided by 2. But that is not the final answer, because the question told us that x here is in quadrant 2. And we know that cosine is negative in quadrant 2. And so for our answer to be correct, the cosine, we need a negative sign there to confirm that our answer is correct, because cosine is always negative in quadrant 2. Alright, for the third question, we are asked to determine the exact value of tan 75 degrees using trigonometric identities. Now for trigonometric identities, there are a lot out there, but you have to think critically on which identity you can use to solve this problem. I would pick the sum and difference identities, because I would be able to solve the problem quickly and much. Now for this question, we are asked to determine the exact value of tan 75 degrees using trigonometric identities. Now, to solve a problem like this, you need to think critically on what identities you can use to solve this problem. within a short time and accurately. Now, I would suggest the sum and difference identities, and they're of two types. And so you need to pick one which would work best for you. Now, for the sum and difference identities for tangent, we have the first one, which is tan A minus B, which is equal to tan A minus tan B, all of this divided by 1, plus tan A divided by tan B. And then the second one, which is tan A plus B, which is equal to tan A plus tan B, all this divided by 1 minus the product of tan A tan B. Now, we are asked to solve for tan 75 degrees. A and B are angles, so that when you add or subtract, you will get 75 degrees. I would like to use this one, and my two angles would be 30 degrees and 45 degrees. So I would say tan 75 degrees equals tangent 30 degrees plus 45 degrees. And now when I do this, I could substitute 30 and 45 for A and B into this here and solve completely. So I can now say this is tangent 30 degrees plus tangent 45 degrees divided by 1 minus the product of tangent 30 degrees and tangent 45 degrees. This equals the square root of 3 over 3 plus 1, all this divided by 1 minus the product of square root of 3 divided by 3 and 1. Now we solve further. We have square root of 3 plus 3 divided by 3 divided by 1 minus square root of 3, 3, which is equal to square root of 3 plus 3 divided by 3, all divided by 3 minus square root of 3 over 3. Now we are dividing a fraction by a fraction, and when we solve that, we would get square root of 3 plus 3, all this divided by 3 minus the square root of 3. I'm just going to leave it here. Now you could solve further and rationalize the denominator and solve the problem much further, but I'm just going to leave it at this point here.